So my name is Dave Weston, but most people just call me D-Wizzle. You got to come up and bring me a adult beverage if you want to know the story behind that, though. And I run the Platform OS Security Group in what used to be the Windows Group. And I'm going to talk to you today about a concept of constructing zero trust networks using Microsoft technologies like System Guard and conditional access. So how many of you have heard this term zero trust networks? A couple of folks. How many know what it is? It's definitely one of those ephemeral marketing terms, so it'll be interesting if my definition of zero trust matches yours. I'll be highly surprised if it does, but it'll be a pleasant surprise. And so I'm going to talk to you a little bit about constructing it. I actually did a talk at Black Hat this year, where I went through each of the vendors and how they constructed zero trust networks and kind of evaluated them. So one of the things I do at Microsoft, in addition to building the OS platform security story, is I also run the red team. So I'm looking at this really from an attacker perspective and making sure it maps up. So I'm really checking myself. I build something and then we attack it. So we've got kind of that virtuous cycle going on. So first, let's just deal with the why would you be interested in building a zero trust network? What's it solving? And we largely exist today in a security model that we can loosely term perimeter, right? This is this kind of aged concept where you set up natting, you set up a firewall, you block traffic from the internet, you're safe, right? Everything's good, you got an IDS, something comes, you detect it and block it. It's this kind of moat concept. The issue with the perimeter concept is it's really built on an old threat model, which is it's built in the day of worms, right? Although WannaCry is a slight counterpoint to that, but it was built in the day of worms where the biggest threat was things coming into your network from open ports. So not to say those don't exist today, but if you look at how networks are actually being breached, if you look at the DNC, if you look at some of the large retailer hacks, really the way those are being compromised are not by network traffic coming inbound, but email attachments, URLs, the kinds of things that are not actually addressed by perimeter security controls. And so what people are saying is, look, I've built this kind of Tootsie Roll network, which is hard on the outside, soft in the middle, and I'm only essentially one step away from an endpoint being compromised and the entire network going down. So case in point, let's take the DNC hack, of which US CERT actually gave us really good data on how this worked. The way it worked is incredibly simple. One person on the network who wasn't particularly trusted opened an untrusted executable. That executable pulled down additional things from a C2. They dumped the password. They moved to the next box. They dumped the password and then recursively built up privileges for the whole network. None of the network controls, none of the perimeter controls actually helped at all because everything was centralized on the outside. There's no concept of trust in the middle. And so as we've seen this rinse and repeat attacker kind of play-by-play or playbook, more and more people have said, the model I have is just simply wrong. And they're looking for an additional model. Additionally, it's fairly complex to build a perimeter network. You've got IDS, you've got taps, you've got all of these things. And so the costs associated with those, when they don't add up to security value and you're still going to get pwned by a single macro being clicked or a phishing attempt, don't make a ton of sense. And then the final thing is in kind of the BYOD model, where people want to grab a device, they want to grab a mobile device like iOS, they want to grab a laptop, and they want to plug right into native services, Dropbox, M365 stuff, backhauling that traffic through all of this apparatus to have it not work makes less and less sense. And so what we really are seeing is two value propositions converging here to say we need a new network architecture. Cloud native, where people don't want to backhaul traffic through these legacy kind of network parameters. They want to go cloud native on whatever intelligent edge device can talk to the cloud. And by the way, even when I do backhaul the traffic, it's not helping me. So that's where we've gotten with the perimeter-based model, and so people are looking for something different. So I've done this quickly, but let's just replay it graphically. So we've got an attacker, he's interested in popping your network. This really loose leaf sign represents your firewalls, all of the things that are on your ingress and egress points from the LAN to the WAN. If you send a single phishing attack, could be untrusted executable, could be a macro file, a simple endpoint attack. relatively quickly, and I can tell you even on the Microsoft network, this is something we do regularly, operationally test, is because there is transitive trust, there are trust relationships between all the things on the LAN, they're implicitly trusted, very quickly you run into the entire network being hit through lateral movement and expansion. So zero trust sort of flips this model on its head. It says, let's pretend for a second there's no perimeter at all. There's no network apparatus that are going to help us here. What are the things we can do to construct secure networks assuming breach, assuming that an endpoint will be constructed? And there's a few things you can do there. The first is you can build into a cloud-based access and identity model something like an AAD or a competitor product, the idea of user trust. So you can say, every time you access something, I want to make sure within reason that I have multi-factor authentication applied to that I understand that you're geo-fenced. You don't come normally from Palo Alto, California, and one day you're coming from North Korea. And I'd like to assign all of those policies to the user identity. That gets things started pretty well, right? That says the things like phishing attacks or identity attacks start to be mitigated, even in the case where I'm not inside of this VPN-based perimeter. So that's pretty cool. Now, for the other part of this equation is, it's not sufficient to just trust the user. Why? If the device gets popped and the user just did multi-factor authentication, everything looks good. There's a cookie there that's got a couple of days timeout. The attacker gets on the machine, they take that credential, they start moving. So it's not sufficient to just do the user. We need to have strong trust in the device and strong trust in the user, and in combination, we need to use those for every access request to the cloud. But if we can establish this device is healthy, there's no antivirus detections, the policies that we expect to be there are set, and the same thing for the identity AAD in combination, using something like conditional access, we can actually construct a fortress via a single user without all the cost of the perimeter. And that's really the value pitch for zero trust networks. So let's evaluate that same hypothetical breach with zero trust. Now notice there's no perimeter. That means there's no free lunch. This machine can't talk to this machine, can't talk to this machine without going through multi-factor authentication via AAD and without attesting to the device health using conditional access. So attacker sends in an attack on a single endpoint. Yes, that initial endpoint gets popped, but when the attacker goes to look for other trust relationships, one of two things are going to happen. One, those are completely cut off, or two, the enterprise is going to force a device policy that says, there's no detections that would be indicated by this attack, and the user identity is healthy. So in those cases, we'd essentially stop the breach, because as soon as the device integrity goes low, it's game over. We shut off access to that device and or user. So because each request has to go through these multi-dimensional access control, we lose this concept of transitive trust where you get it just because you're plugged into the Wi-Fi or plugged into the Ethernet, and we assume that a device has to prove itself as secure, hence the term zero trust. So the trust determination comes from a couple of things. Primarily, the architecture we're proposing here is built on top of Microsoft's conditional access. How many of you are familiar with conditional access? Cool, great. So not only is Intune very effective, obviously, for enterprise management systems, but using the information that Intune has, we can actually make security policies that will help us construct a zero trust network. So what's a security policy you might be able to use with Intune? One, is this device provisioned for my network? So if you just take a laptop in and I don't own it as the enterprise, it's not MDM managed, even if you have the user's password or the token to access the cloud, I don't want you to do that, right? That's a risk indicator. That stops the attackers from just sending in a phishing attack, taking the credential, putting it in their VM, and then connecting to my enterprise. So that's a thing Intune can help with. Number two is Intune is able to pick up policy signals on the device. So a good example of that is, did I set an application control policy on this device? Does this device have the latest patch level? Does this device have exploit guard or some advanced capability? So Intune is really going to be the device inventory and the collector of the device policies that we're going to use for each and every access request. This is incredibly useful, and since you already have it on your network, it actually makes building a zero trust network much simpler. So the Microsoft's approach to constructing a zero trust network with M365 builds on 3 pillars. The first is what we call device integrity. And there are multiple ways where Microsoft, we like to build 3 ways to do the same thing, always to confuse you. That's a joke, okay? You guys can loosen up. So we have multiple ways to do this, but the most effective way, bar none, is to use Windows Defender ATP as the trust indicator for a device. What does that mean? That means is if someone sends in a piece of malware and it meets a behavior or it emits a signal that the intelligent security graph determines is malicious, we should instantaneously degrade the trust of that device. Right? So going back to that scenario, as soon as I open that executable and ATP sees it, I want it to tell all of my organization, cease access for this device. Okay? And ATP is able to do that because it's ever vigilant, not only watching what's happening on the device, but sending those signals into the cloud so we can compare it to known good and known bad across the entire enterprise universe. The second thing I already touched on, which is Intune collaborates with ATP. So ATP identifies attacks, Intune provides policy compliance, and those 2 things together give us the ability to reason about whether the device is trustworthy or not. A really good simple example of that is if you're not running the latest and greatest high-tech security policy or features on your Win 10 device, maybe I want to allow you to access a wiki, but I don't want you to go to the Joint Strike Fighter plans or the nuclear plans. To do that, I want to scale up your requirements. And that's one of the coolest things about the combination here is it's never a binary decision, it's a gradient decision. So even if someone gets an infection, if it's a relatively minor infection, you can protect your most sensitive resources by degrading the things they have access to while still allowing them to be productive enough to say, find the IT number or give a call, okay? Now that left side of the equation really defines the device trust story, but on the right side, we're defining the identity story. Remember, I told you those 2 things in combination are how we're going to understand the security of this device without the security of the user access without all that extra goo on the ingress or egress points of my network. And Azure AD has multiple controls for a particular identity. For example, you could author a policy that says, I don't want any user to access anything on my network outside of country X. And we could use geolocation on IPs and other forms for sort of geotagging to determine that policy. Or we might want to say, if there's an indication of lateral movement, for example, a golden ticket attack or some other indications of anomalies related to a user authentication, maybe they work in sales and all of a sudden they're downloading every engineering document from OneDrive, we can actually spot that anomaly and use that to reduce access. So that's really useful. We can also do things like say, you're in the sales group, you shouldn't access engineering resources after 8 p.m. There's all sorts of flexible policies there. And you can also combine that with multi-factor authentication, secure biometric policies. You could even require a U2F or a FIDO token, which are the latest and greatest hardware tokens. So you have really fine-grained methods to say, this is the bar I want to set on the identity, so I'm sure it's not compromised, and here's the bar on the device, and in combination, here's that really flexible policy. Now, you're cooking, right? This is the stuff that's going to help you with those modern attack techniques. It's much more effective than I would say the classic perimeter model. So I wanted to point out one additional thing. So hopefully I've already shown you that we have really flexible systems here for identifying why a device would be trusted, but I want to go even a little further. How many of you are familiar with Microsoft's virtualization-based security story? So one of the things we do to stop even a malicious admin from doing things like credential attacks or modifying or tampering with the device is we actually put credentials and other secrets behind what we call the hypervisor boundary. So the hypervisor is this hardware-based technology that allows us to segment workloads in the cloud. And what we did is we shrunk down that same Azure Hyper-V technology to create a very tiny hypervisor that holds secrets. Even from an attacker who gets all the way to kernel, they can't cross that boundary. And one of the cool things that we've done in the Microsoft Zero Trust story is we've hardware rooted the device trust. What do I mean by that? It means I'm using the hypervisor as this kind of secret, let's call it like a drone or an overwatch on the device that cannot be tampered with, and it watches and sees everything that's happening on the device from a hardware-backed position. And by using that, we can be sure, even if an admin gets on the device, since they can't cross the hypervisor boundary, we still have authentic signals on whether the device has been tampered with. So we're creating this kind of impenetrable black box that's watching the device. So I wanted to show you quickly, I'm actually running out of time here, but I wanted to show you relatively quickly, I'm actually going to skip through that. It's just 5 minutes left. I'm going to kind of skip through that. So just to touch on this a little bit more, the system guard runtime, this is the hypervisor-based component, actually watches all of the critical processes on the system and makes sure they can't be shut down or tampered with even by an admin. So I'll give you an example. If you've got ATP and it's humming along great and it's giving you all the signals and all of a sudden it goes dark and you have nothing, do you want to allow that device to access your most precious cloud resource or not? You don't. In a world where you don't have a hypervisor, you're not capable of understanding, did this get shut down by a clever attacker or did the user just go offline? Because you need this hardware-rooted signal that you can say, even in the worst attack possible, this is still going to be my source of integrity. We can use the system guard as overwatch for things like, did the device boot securely with firmware by the OEMs I determine? Is the antivirus component running correctly? Is the firewall up? Are the credentials stored in via Windows Hello and Windows Credential Guard? All sorts of things. So this is really a unique feature set that you're not going to get outside of Windows, and something we think is really critical. And because of this combination of System Guard with ATP as Overwatch, we're able to say not only are we able to get hardware signals, but we're able to get deep introspection of things like macros, PowerShell runtimes, Python, authentication anomalies, all happening on the device, and those are all streamed up through conditional access and AAD and applied to every resource access. We've actually increased our investment here on the hardware side because we think in today's current threat climate and the threat landscape that more and more attackers are moving down into the hardware as a means to evade the security software that lots of enterprises are deploying. So put yourself in an attacker's shoes. If you want to compromise company X, and you know they've made a huge investment into Windows ATP or CrowdStrike or something competitive, the attacker is going to take a look at things and say, hey, what laptops are deployed in that environment? Are they up to date? Are they vulnerable to Spectre and Meltdown? Do they have old TPM issues, et cetera, et cetera? Hardware has become critical path in the attack chain and in the trust chain. So what we're seeing in our world as we investigate breaches is more and more interest for attackers moving into things like firmware, exploiting vulnerabilities in firmware to hide their code in a place where EDRs and other software that's monitoring the device simply cannot see it. So in the firmware of your laptop that are sitting in front of a lot of you has full control of the system, has full capabilities to read and write any piece of memory, full capabilities to touch any peripheral, and there is absolutely no logging or detection capabilities inside the firmware. So we've actually partnered with a few of the most popular OEMs out there, Dell, Lenovo, Panasonic, and Surface, to implement a new hardware feature set that allows us to attest to the security of the firmware, giving us that visibility we didn't have. We call that System Guard firmware protection. In the latest version of Windows, RS5, you're able to manage that through MDMs and GPOs, and you're able to attest to firmware protection as a requirement for conditional access. And in combination, that allows you to say, one, this device is able to detect any tampering all the way down to the hardware level. And if that tampering does exist, we have automatic access and authentication blocking on that particular device. So this is a real innovation and something you should look for as you're moving forward for things like hardware refreshes. This is a capability that's going to extend out even into the most advanced attacks. Talked about this quite a bit. There's a couple of things, nuances that are pretty interesting inside of conditional access that you might want to think about. For example, how many of you using things like Windows Defender Exploit Guard to turn on extra protections on your network? Anyone doing that? So Windows Defender Exploit Guard is sort of the child to...
Microsoft Ignite
Whoa.
attendees. The expo is now closed.
When they said 6, they meant 6.
The expo will reopen tomorrow morning at 10 a.m.
All right.
Thank you and have a great evening.
So I'll continue this at 10 a.m. I'm just kidding. Where was I? So Windows Defender Exploit Guard is a derivative of technology called Emmet, which some of you might have heard of. And what that technology allowed you to do is select key processes in your system to provide extra protection. For example, if you've got a line of business app that's running an old version of Java or .NET that you can't just upgrade, you can use Exploit Guard to apply additional policies there. Now, it's one thing to apply those policies, but you've got users maybe who are admins, you've got churn in your systems, you've got flatten and rebuilds where configurations get lost. What you're able to do with Intune is mandate that those configurations are present for users to access particular resources. And that's really key because it allows you, like I said previously, to scale up and have this spectrum of security requirements that are tied to the resources that are being accessed. So if you don't want to annoy users or add extra protection where it's not needed, you can author policies, but the second they come in and touch a high value asset, you can raise that bar with a policy requirement and conditional access, and that is an incredibly powerful tool. A couple other places where you can actually apply conditional access. I've talked largely about native cloud integration, so SharePoint, email, Word, of course all of those things are possible. But with federated identity, using things like AAD, you can actually apply this to third-party services. So for example, if you did a SAML or federated identity integration with a GitHub or a Salesforce or et cetera, you can actually apply all of these conditional access policies to the entire public cloud in your space. So you could do something like audit all of the applications that are in use in your enterprise, especially from third parties, do a federated identity integration with them, and then apply conditional access policies depending on the sensitivity of that data. And that's a really powerful tool. The other thing you can do is for non-cloud applications, you can actually take a server role called an identity proxy. You can put those applications behind this server role, which is essentially the IIS server, which every time a request is made, before it passes that request on to the target application, calls out to the cloud and calls out to Intune to make sure the device is compliant and the identity is compliant before allowing access. So this is an incredibly valuable way to take existing on-prem applications that you're concerned about and put zero trust concepts on top of them. And as you move to the cloud, more and more things will hopefully go cloud native, but you're going to have these lingering applications. I know we do on Microsoft's corporate network, and this proxy is an incredibly useful way to mitigate the risks from those. So I'm going to wrap up and let you folks partake. So a couple of things I wanted to leave you with is, as usual, we think one of the advantages of the Microsoft 365 Zero Trust approach is all of the things that you need to use here, the policies, ATP, system guard, all these powerful constructs are simply built into Win10. There's no agents to deploy. Your perf isn't going to bottom out as soon as you turn these on. You're not going to have configuration issues. You're not going to have to deal with a third-party vendor. It's just going to be there. The second differentiating factor is only Microsoft has that vertical engineering of owning the OS kernel, owning the hypervisor, owning the client, and the whole cloud to build this vertically integrated story that roots trust all the way down to the hardware, which is the gold standard. You have an end-to-end solution with just an E5 license. You can literally build this entire thing with just E5. And you're enabling users to have more freedom and more productivity while not lowering security, actually raising it substantially by moving away from backhauling traffic through legacy perimeters. And you get visibility in a different way. So you're not necessarily getting it down at the packet level, but through ATP, you're getting all the visibility into the device. And through constructs like Azure Active Directory and other Azure logging constructs, you actually have the same visibility you would have through network packet capture, but in a much more flexible and scalable manner. So that's all I have. Thank you. You're free to get some beers. Yeah. If there's any questions, I'm happy to take them. I've been instructed there's a hot mic. Questions? All right, here you go.
So currently the exploit guard only works with Windows Defender. Is there any plan to support for any third-party antivirus solutions?
That's tricky because what you're doing with exploit guards, you're actually configuring the Defender engine to enforce policies. So exploit guard simply is a user configurable mode for Defender. Now we've looked at certain areas where they wouldn't interfere, but ultimately it's a bit of a difficult thing to have two antiviruses sort of fighting over the same resources to do the monitoring. So I think in reality, for the foreseeable future, it will be a Defender only. Questions? All right, thank you very much. Oh, you had one.
So the access is blocked, the conditional access is blocked on the network level or on actually when accessing the application?
So it's when, accessing the application. The way it works is you would put either via a reverse proxy that would use network sort of the traffic as the control point or actual AAD authentication. It would call onto Intune, ask, hey, is this device policy compliant? Then check the identity compliance, MFA, et cetera, and allow it. So you're enforcing either at the network if you're using Proxys or purely at the application integration level. Yeah. So do you mean like the attack surface is still exposed? Yes. The on-prem proxy, technically no. You could set it up as a reverse proxy where the port's just not exposed. It has to go through there. But in the native case, yeah, you're going to have port 80 exposed on Azure, which, we hopefully will take care of that, and that's not an issue.
Can this be combined with Zero Trust other vendors?
You certainly could. If you wanted to do, say, micro-segmentation, where you've got point-to-point validation, say, with network peripherals, and then on top of that, you want an application layer kind of higher up the OSI stack, absolutely, you could do that. And they wouldn't interfere very much. You would just have to ask yourself, from a security perspective, what's the additional value there? Cool. Thank you.